welcome you all my lecture series of automata theory and compiler design. In the last video we have seen what is a push-down automata. In today's video we are going to see about the example automata using that push-down model. So I recap the session. So what is a push-down automata? Push-down automata is a ways to implement the context-free grammar. It is a similar way to design a finite automata for regular grammar. So it is a type 2 grammar, and it is more powerful than the finite automata. So the pushdown automata, it is a combination of the finite automata and stack. So the components of the pushdown automata is we have an input tape and a finite control unit, and also you have a extra stack memory to store the history of data. So the pushdown automata mainly used to store, suppose any language require the history of data, means need to store the history of data, means that type of language used to are the pushdown automata. For example, already we know that what are all the definition of the pushdown automata. It contains the 7 tuples. It is a queue, it is a set of states and input symbols, and also the finite stack alphabet, that is call it as a tau symbol or the uppercase gamma, and the transitions, and the q naught is a starting state of that automata, then z naught is a starting symbol in the stack, and f is a finite set of states. So the pushdown automata contains the 7 states, 7 tuples, and the transition in the pushdown automata means, for example, we have an input symbol A and A comma B tends to C, that is the transition from one state to other state is required. So A is the input symbol and B is the stack top symbol, and C is the symbol is going to push. So this is the transition in the pushdown automata. Now here the finite, already we know that in the finite automata the transition is from the single state. When you read the input symbol, it goes to the next state. But in the finite, in the pushdown automata, we have a state. From that we have the transition is A comma B tends to C. So A is an input symbol, it may be a epsilon or any symbols. Next B is a symbol on top of the stack. This symbol is going to pop. Suppose the epsilon is neither popped or read, that is the term in the B term. Next tends to C means we are going to push into the stack, that symbol is pushed onto the stack. So the epsilon means is nothing is pushed, means suppose you have a symbol na, that symbol is pushed onto the stack. So this is a transition of pushdown automata. For example, considered the example is construct the pushdown automata that accepts the number of 0 follow equal to the number of ones. For example, the language contains a 0 power n, 1 power n, or n is greater than or equal to 0. So this is the language. For that we have to construct the pushdown automata. So the pushdown automata is a non-deterministic. That means for everything we have it is a non-deterministic, means we don't need any input symbols go to the single state. So what is the language we can derive from that? What are the strings we can derive from the language? 0 power n, 1 power n means 0, 1. So any number of 0 equal to the number of 1. So 0, 0 means it followed by the 1, 1. So this is the language we can generate. So the length of the string, for example 2 means, so what is the language it could be generated is 0, 0, 1, 1. So now we have to construct the pushdown automata for that 0, 0, 1 acceptance. If I start with the Q naught, so the transition any pushdown automata, first we have to push the stack short symbol to that stack z naught, and finally we have to pop that z naught. So epsilon comma epsilon tend to 0. Here there is no input symbol is read, nothing is to be popped, but we have to push onto the z naught onto the stack from the state q0 to the q1. Next thing is q2. From the q2 we have a transition is 0 comma epsilon tend to 0. So the input input symbol reading is a 0, nothing is popped, but we have to push on to the 0 onto the stack. So next reading symbol is 0 means again the same Q2. From the Q2 we are reading that 0, nothing is popped, but we have to push that input symbol 0. So next from the Q2, next reading symbol is 1. So next is a 1 means 1 comma 0 tends to epsilon means the reading input symbol is 1. What the symbol we have to pop from the stack means 0, nothing is pushed. So this is for when you read the symbol 1. Next from the again you are going to read the symbol 1 means from the Q3 state we have a transition is 1 comma 0 tends to epsilon. So the 1 means the input symbol reading is a 1. You are going to pop the symbol from the stack is 0 and nothing is pushed. So the when you reach the end of the symbol, so now so far we are reading 0 0 1 1. So finally we are going to pop the Z0 from the stack. So what is the transition? Nothing, input symbol is read, but Z0 is popped, but nothing is pushed. So epsilon comma Z0 tends to epsilon, we reach the state Q4. So the stack push and pop is 0 0 is pushed. Once you 1 1 is read means the 0 0 is popped. Finally we have the Z0. So this is the diagram for that language 0 power n 1 power n for the string 0 0 1 1. I hope you will understand how the push-down automata is constructed using the transition of A comma B tends to C format. Thank you.